Good day, my name is Muhammad Nasser Abdurraouf. I'm here to give online tutorial specifically on some selected topics in chemistry. Specifically, we are going to talk about organic chemistry, types of organic chemistry, all this functional group. We talk about isomerisms, we talk about positional isomerisms, we talk about functional groups, we talk about hybridizations, and so on and so forth. So let us start. We have what we call organic chemistry. Organic chemistry is basically refers to as a branch of chemistry that deals with the study of carbon compound only, with the exception of thiazocarbonate, the carbon dioxide, as well as hydrogen thiazocarbonate. So when you talk about the study of carbon compound only with exceptions of thiazocarbonate, such as the thiazocarbonate is a CO3, we have hydrogen thiazocarbonate, and we have also CO2. So this is exceptions of this for the study of carbon compound alone with some specific elements such as the hydrogen, the oxygen, sulfur, and phosphorus are also referred to as the organic chemistry. And organic chemistry can also be referred to as the study of carbon and its compounds, the carbon and its catenation, the carbon and the covalent bond with other substances or other elements, respectively, as the case may be. And based on these hydrocarbons, the backbone of this organic chemistry is referred to as hydrocarbon. A hydrocarbon. From the name, hydrocarbon is derived from two things, which are two elements. We have the hydrogen and carbon. The hydrogen and carbon, which is covalently bound together, that refers as the hydrocarbon and is the backbone of organic chemistry. And these hydrocarbons are basically subdivided into two. We have what we call aliphatic hydrocarbon, and what we call aromatic hydrocarbon. When we talk about the aliphatic hydrocarbons, these are hydrocarbons are specifically subdivided into two. We have the saturated and unsaturated. We have the saturated and unsaturated. Saturated aliphatic hydrocarbon, and we have unsaturated aliphatic hydrocarbon, respectively. When we say saturated aliphatic hydrocarbon, the saturated aliphatic hydrocarbon, this is hydrocarbon that is made up of only single bond. An example, we have what we call alkene. And unsaturated aliphatic hydrocarbon, this is types of hydrocarbon that are specifically made up of two things, either the double bond, which is alkene, or the triple bond, which is alkyne. So we divide into two. We have what we call alkene, which is the double bond, and we have the alkene, which is a triple bond, as the case may be. Now, permit me to digress into the aromatic hydrocarbon. The aromatic hydrocarbon is divided into two also. We have the benzene and its what? Derivatives. Benzene derivatives. Example of benzene, we have the C6H6 and the benzene derivatives, which including the phenol, which including toluene, which including benzaldehyde, benzanoic acid, as the case may be. And based on this aliphatic hydrocarbon, some of these aliphatic hydrocarbon can be subdivided also into two. We have what we call cyclic and acyclic. The cyclic aliphatic hydrocarbon, this is types of hydrocarbon that specifically is found in the ring shape. Example of these cyclic hydrocarbons, we have what we call cyclopropane. This is aliphatic under the cyclic hydrocarbon. We have the acyclic hydrocarbon. This is cyclic, and we have the acyclic. From the name, acyclic simply means this is types of aliphatic hydrocarbon that specifically found either in a straight chain or branch chain, as the case may be. And that leads us to we digress into what we call functional group. What do we say about functional group? A functional group is refers to as the groups of a member of various compound under the hydrocarbon specifically that is specifically identified by specific functional group. And based on this functional group, we have several functional groups. Example of one functional group, we have what we call alkanol. The alkanol, the functional group is OH. We have what we call aldehyde. Aldehyde, the functional group is CHO. We have what we call ketones. The ketone family, the functional group is CO, that's RCO. We have what we call amines. And the functional group amine is RNH2. We have what we call amides. And the functional group of amide is RCONH2. We have what we call alkanoic acids. We call it alkanoic acid. And the functional group of alkanoic acid is RCOOH. We have the ester family, and the functional group of ester family is the RCOOR prime. We have what we call ether, and the functional group of ether is ROR, and so on. We have the various functional specific group. We have the alkanol, and the functional group is OH. We have the aldehyde, the functional group is CHO. We have the ketones, the functional group is RCOH. We have the amines, the functional group RNH2. We have the amide, the functional group is RCONH2. We have the alkanoic acids, the functional group is RCOH. We have the esters, the functional group is RCOR prime. And we have the ether, the functional group is ROR, as the case may be. And based on this, we talk about hybridization. Hybridization is defined as a phenomenon, or is referred as a process of mixing two or more orbitals of the same energy level or different energy level in order to form a new substance which is called hybrid. I repeat, hybridization. Hybridization. Hybridization is defined as a phenomenon of mixing two or more orbitals of the same or different energy level to form a new substance which is called hybrid. And based on this hybridization, there are three types of hybridization. We have three types of hybridization. We have what? sp3, we have the sp2, and we have what? sp. The sp3 are the family of alkene. An example, we have methane, and this is methane CH4. We have the sp, and the example of sp2 is alkene. An example is ethane, which is C2H4. The last one is sp, which is alkyne. And the example of it is ethyne, and this is C2H2, as the case may be. And this is the structural formula of it: H, 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 H. And this one is C double bonded. We have H, 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 H. We also have this, which is C triple bond. We have what? H, H. This is a functional group. This is the condensed or molecular formula, and this is the name, and this is the family in which it specifically belongs. So that's lead us to go to what we refer to as isomerization. When we say isomerization is defined as a phenomenon where a compound have the same molecular formula but different structural formula. I will come again. Isomerization from the isomer. Isomerization is defined as a phenomenon where a compound have the same molecular formula but different structural formula, as the case may be. And we have types of isomerization. We have, number one, we have positional isomerization. We have functional group isomerization. We have nanomerism. We have geometry isomerization. We have chain isomerization. Let's now see one after the other. When we say positional isomerism is the types of isomerism which means the functional group is changed. For instance, if you have the CH3, the CH2, the CH2, CH2, and OH. If you want to name this compound, this is a family of alcohol, and you have to start from here. 1, 2, 3, 4. This is butane. This is what we call N-butanol. N-butanol because of the OH. Normally it's butane without OH, but when we have OH we call it N-butanol or butanol. If we shift the position of the functional group, which is OH, we shift it to carbon 2, we are going to have CH3, we have the CH2, we have the CH, we have the OH, we have the CH3. Now this is what we call positional isomerism. They have the same molecular formula but different structural formula. And to name this, you count 1, 2, 3, 4. This is called 2, or we call it but2R. We call it but2R. That's how you call it, or you call it. That's how you can call it just but2R. This is a positional isomerism, especially. And based on this, we proceed to our functional group isomerism. When we talk about functional group isomerisms, we talk about the isomerism that specifically deals with functional group, respectively. For instance, we have CH3, we have CH2, we have the CH2, we have the NH2. This is a family of imine. And to name this compound, you count 1, 2, 3. This is referred as propylamine. Propylamine, or you say propylamine, as the case may be. This is what refers as a functional group isomerisms. Let me go to the tautomerisms, but the main important one is the geometric isomerism. In geometric isomerism, this is isomerisms that can undergo geometric in nature. And when they say geometric in mathematics or in engineering terms, it means it has to have a fixed shapes or ring shapes, which this geometric isomerism is divided into how many? 2. We have the cis geometric isomerisms, and we have what? The trans geometric isomerisms. For instance, if you have the C double bonded, we have the CH3, here is H, here is the CH3, here is H. If you want to name this compound, you count 1, 2, 3, 4. These are in trans to each other. This is what we call trans. If they are trans to each other. But if we have the same compound, we have C double bonded with the H, CH3, the CH3. This is trans, is cis to each other. This is cis to each other, while this is trans to each other. To name this compound, you count 1, 2, 3, 4. 4, and it's placed under the family of alkane. It's going to be but2-ene. But2-ene. But it's trans. You say trans, but2-ene. But this one is cis. You call it cis, but2-ene. And this is referred to as the geometric isomerisms, as the case may be. So based on this, we specifically proceed and also go about to talk about homologous series. Homologous series is referred to as a phenomenon where an organic compound or a members of the same family differ from each other based on NCH2. I'll repeat, homologous series. Homologous series is referred as a phenomenon where a member of each groups of this organic compound or these hydrocarbons differ. The two members differ successfully based on CnH2, as the case may be, and there are some characteristics of homologous series. Number 1, homologous series. Number 1, each successive member will differ from CnH2n. That's number 1. Number 2, each successive member, they have a similar method of preparation. 2. 3. Each successive member have the similar chemical and physical properties. and each successful member will have the same functional group that will be the same down the group, and each of the successful member can have their physical properties varies respectively either down the group or up the group as the case may be. And based on that, we now we digress into the alkane, alkene, and alkyne, and talks about each of their properties respectively. So let's talk about alkene. Alkene is also referred as what we call paraffins. And general molecular formula of alkene is CnH2n plus 2, where N is the number of the atoms, respectively, is the number of atoms of carbon. For instance, if your N is 2, if you want to substitute the value from the formula, we have what? C2H2 2 plus 2, which means we have what? C2H 2 times 2, 4 plus 2, 6. So as C2H6, as the case may be. And these alkanes, respectively, let's talk about the chemical properties of alkane. Number one, alkanes undergo what we call combustion. And combustion is a type of reaction that is generally for all organic chemistry. And what is combustion? Combustion reaction is a reaction whereby a successful member or any alkane member, any alkane family or any organic compound family burn in air to produce carbon dioxide as water, respectively. For instance, if we have the CH4 plus the oxygen, we give us C2H2, respectively. This carbon dioxide and this water. Let's see how to balance the chemical equation from here. We have the C, here is the C, H4, and here is H2. Automatically to balance, what is in right hand side must be equal to left hand side. To balance chemical equation is, this is hydrogen is 4 here and hydrogen is 2 here. To balance it up, you had 2 to here. You had 2 to here. There is C1. The H4 here is also H4. 2 times 2 is 4. The oxygen here is how many? Is automatically is 2. And oxygen here is 2. We have 2 here. Oxygen here is 4. And here is 2. To balance it, you have 2 here. That's how to balance the chemical equation. This is what we refer as combustion. It's a phenomenon where any organic compound burn in the presence of air to form carbon dioxide as water. And this is one of the properties, or one of the chemical properties of most of alkane, alkene, and alkyne. They undergo combustion reactions. We also have what we refer as additional reaction. The most of the times, additional reaction specifically is a reaction which is limited to some extent the unsaturated aliphatic hydrocarbon to convert them to become saturated. For instance, if you have the C2, the H4, respectively. If you had, let's assume you had chlorine to it. When you add chlorine to it, there's going to be a constant value that you're going to have. What is the constant value is? When you add this to this, you are going to have the C2H4. And how many chlorine? CH2. If you want to do the structural formula is C double bonded with carbon, 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 and carbon plus chlorine. The reaction usually occurs under UV light. That's how as catalyst. What happens is that the chlorine, because of the negative effect of it, electronegativity, will come and break down the bond to form single bond. Now we have the H, we have H, chlorine, chlorine, H, H. And if you want to name this compound, how do you name it? You have 1, 2. If it's 2 carbon, we call it ethane. We can have 1, 2. It's going to be 1, 2, di. Why is it di? Because attachment there is 2, which is chlorine. And we don't call it chlorine, we call it chloro. 1, 2 dichloroethane. That's the name. So you can see, in a nutshell, we convert unsaturated to saturated through a process called additional reaction. It can be bromination. This reaction is called chlorination reaction. Chlorination of alkene. And it can be bromination of alkene. It can be iodination of alkene. It can be fluorination of alkene. It can be iodination of alkene, as the case may be. So, and so on and so forth. So last end of little things I'll talk about alkene family. Now let's digress to what we call alkene. The alkene is unsaturated. Alkene is unsaturated and is having a double bond, as the case may be. And they have a general molecular formula of CnH2n H2N, where N is equals to 2, you say what now? C2, H2O2, and you have C2, this time this is H4, and if you draw it, you discover that it's complete. H, 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 H. This one is called hethane, or you said it's one in. That one is indicating the position of the double bond, as the case may be. So it also undergoes combustion, it undergoes additional reaction, but in this kind of additional reactions, it also undergoes additional reaction. I think we have explained that earlier. It can undergo combustion, it can undergo additional reaction, and there's something I also forget. There's what we call substitution reaction. Substitution reaction. And this substitution reaction, it usually occurs specifically to alkene family, which is saturated. How does it start? We have a chlorine, CH4 plus 2 chlorine attached. You are going to have the HCl plus, if you remove one hydrogen from here and you have this chlorine here, you have HCl. Now if you observe, if you remove one hydrogen here, what are you going to have? CH3, you write CH3. You have one chlorine to the hydrogen removed, it's going to remain chlorine, you had it here. So this is what we call chloromethane. Take this to step 2. CH3Cl plus Cl2. Automatically this is constant, which is HCl plus. So what happens is they remove one hydrogen here and remove one chlorine here, you have HCl, right? If you remove one hydrogen here, what is left is CH2. Then you have your Cl. Remember, Cl plus Cl will give you Cl2. If you observed, as the hydrogen is reducing, the chlorine is increases respectively. So you pick this, you go to the third equation, we have what? CH2, chlorine 2 plus what? CH, the same thing, HCl is constant plus, if you remove one hydrogen here and you remove one chlorine here, you have HCl. What is left here is CH. We have one chlorine here and we have also 3 chlorine here. It's going to be CH3, as the case may be. Remember, as the hydrogen is reducing, the chlorine is increasing respectively. You pick this, question 4, CHCl3 plus Cl2. We are going to remove one hydrogen here. We have with this, we have what? HCl plus, no hydrogen is left here again, it's going to be C. We have 2 ion chlorine here plus 2. We have what? CCl4. This is chloromethane, this is dichloromethane, this is trichloromethane, and this is one is tetrachlorocarbon, as the case may be. And this is reaction is called substitution reaction. And let's talk about the last one. The last one is the alkyne family, having the general molecular formula of CnH2n minus 2. So whereby if n is equals to 3, you have what? C3H2 3 minus 2. C3H, here is what, this time this is 6. 6 minus 2 is 4. So it's going to be, how do you write it? You write 1, 2, 3. And triple bond must be there. 1, 2. So if you have one hydrogen here, 1, 2, 3, 4. There's no need of putting hydrogen because the outermost electrons that are specifically found in carbon is 4. It's complete. Then we have one hydrogen here, one hydrogen here, one hydrogen here. If you count the number of carbon, 1, 2, 3 is 3, satisfied. We have hydrogen, 1, 2, 3, 4. 1, 2, 3, 4, satisfied. And this one is called propane. We call it propane. Or you say prop 1N, as the case may be. And this is all about the short dedications on the organic chemistry, just brief.